Okay, so today what we are going to see, today we are going to see two more algorithm of data science, machine learning. So in last class we have seen SVM, which is a very good classifier, right? We have seen the theory as well as the practical. So today what we are going to see is like we are going to see two more classification algorithm, supervised classification algorithm. One is for supervised classification algorithm and one we will see unsupervised algorithm. Okay, so what we are going to see? We are going to see k nearest neighbor and k means algorithm. Okay, so so before jumping into programming, let's start with the theories, like what exactly the theory is. So let us start with k nearest neighbor. Okay, so k nearest neighbor is a supervised machine learning algorithm. Okay, so we are in the last class we have seen SVM. SVM is one of the supervised classification technique. Similarly, KNN is also one of the supervised classification technique. Okay, so what is the theory behind that? If you want to read more about the theory part, I had told you the book, right? Introduction to Statistical Learning. Okay, please read the chapter number 4 of that book. Okay, for more theoretical knowledge. So now what exactly a KNN algorithm is doing? It is as simple as that. It is nothing but a simple, very simple mathematics involved into it. So KNN is nothing but K nearest neighbor. Okay. So what exactly we are doing here? K nearest neighbor is a classification algorithm that operates on a very simple principle. It is best shown through example. Okay, so let's understand the algorithm through an example. So let us imagine that we had some imaginary data on dogs and horse. Okay, so we have this data set. So what exactly I have? I have dog and horse data set. So what the features? What are the two columns available? So we have weight and height column. Okay, so basically here, can anyone say how many classes are there? The columns are weight and horse. Okay, and finally the target column is whether it is a horse or it is a dog. Okay, so in total we have three columns. First column weight column, second column height column, and third column is the animal category, whether it is a dog or a horse, right? So what is my problem statement? My problem statement is we have a data set which consists of the height and weight records for horse and dog. We have to use that data set and we have to create a machine learning model so that in future if I give you a horse, if I give you a weight and height, you should able to tell me which category the particular animal will belong to. Okay, understand the problem statement? Let me repeat again. The problem statement is, the horse and weight sorry the height and weight records of horse and dog. So you have to train the model using this dataset so that in future if I give you a new data with weight and height record, your model should able to predict which class it belongs to. Either it is a horse or it is a dog. That is the problem statement. Okay, so what I did, my entire data set I represented in a two-dimensional space. Height and weight I represented. So you can see the horse and the red colored dots are nothing but the horse data and the blue color dots are nothing but the dog data. Okay, now what is the problem statement? All these green color lines, green color dots, these are my new data point. Okay, so in the sense these are my testing data points. So what I need to do? This green color dot is a horse or a dog, that I need to predict whether it is belongs to a horse class or it is belongs to a dog class, that I need to predict. Hope the problem statement is clear to you. Now how to do that? How we can say whether the green color is a horse or a dog? Okay, so this is the algorithm behind KNN. What we are doing? The first step is training the algorithm. How we can train the algorithm? And the second step is predicting the result. In training the algorithm, store all the data, and in prediction, what we can do, excuse me, calculate the distance from x to all points in your data. Okay, so here what is x? Let's take any one of the all these green points are x. Okay, let's take any one green point. Let's take the top bottom, sorry, the top green point. Okay, so that is our x. Step number one is calculate the distance of all other points, right, to the test point. That is the first, the top green point. Then what we can do, sort the points in your data by increasing distance from x. First step is calculate the distance. There are so many mathematical way to calculate the distance. For more information, you can read the book. There are 3 or 4 distance metrics like Euclidean distance, Manhattan distance, so many different types of distance. Okay, so using all those distance technique, we are trying to find out the distance of all other points of the data to the point X. This is step number one. Step number two, sort the points in your data by increasing distance from X. And third is predict the majority label of K closest point. Okay, so what we are going to do first, let's take the first top green color. We are trying to find out the distance of all other points to the green color point. Then we are trying to sort all the distance, all the points based on the distance. Then we are seeing which all points are very closer to, let's say here for the top green color dot, if I find out the distance and sort it, obviously most of the points which are which is very nearer to green is red color points, right? So it is a higher chance that the green color dot is belonging to red color class. But if I take the top button, the top sorry, the bottom green color point, and I will try to find out the distance of all other point to the bottom green color, and then I'll sort it according to the distance. Most of the points which I will find is belonging to blue color class. So I can imagine that as most of the points are belonging to blue color, which are most closest to the green color point, it is a high probability that this green color point is belonging to blue class rather than red class. Okay, it is simple mathematics, nothing. This is the main funda. So choosing the k will affect the what class a new point is assigned to. K is nothing but in K nearest neighbor. What is K? That may be the question, interview question. So in K nearest neighbor, K is nothing but number of near neighbor point you want to look into. If K equals to 2, you are going to see the top 2, or maybe the most closest 2 after sorting according to distance, the top 2 closest point of the new point. Okay, which class they belong to, that the new class will belong to same. If k equals to 3, then top 3 most closest point of the new point. If k equals to 6, top 6 neighbor point of the new point. K equals to 10, top 10 after sorting according to distance, top 10 neighbor point to the new point. Okay, so that is a funda. Here you see, so we have to like we have data points we represent in a x dimensional and xy dimensional space. So basically we have two classes, one is yellow color class and one is blue color class. Okay, so the star, red color star in between, in middle, is a new point, right? So how to find out the class of that new point? So let's see for different k values. Let's start with k equals to 3. Okay, so k equals to 3 means what we will do? Step number 1, calculate the distance of all other points to the new point star. So total how many points are there? So there are total,
Three.
yeah. So total, first step number 1 is we will try to calculate the distance of all other points to this point. Okay, all other points, whatever points is existing. Okay, this is step number 1, simply calculate distance, nothing else.
Okay.
Okay, step number 2, sort all the points according to the distance. If I sort, then obviously in step number 2, step number 1 is over. Okay, now if I sort according to distance in step number 2, definitely I will have um, this will be number 1 which is most closest, maybe this will be number 2 point, which is most closest according to distance. This will be most third, right? This may be fourth, this may be fifth, like that, right? This may be ninth, similarly. So now the question is k equals to 3 here. So what I will take? Top 3 I will take. K equals to 5, top 5 I will take. K equals to 10, top 10 I will take. For the first round, k equals to 3 means what I will do? Top 3 I will check. So what is my top 3 points? These two blue lines, blue dots, and this yellow dot. These are the top 3, right? Top 3 neighbors of this star. So then I will check the top 3 neighbors belonging to which class. So I can find out majority of the neighbor, top 3 out of 3, 2 of the neighbors are belonging to blue class. So I can predict that this star is belonging to blue class rather than yellow class. Okay, but the same thing how it is changed when I'm taking k equals to 6. So k equals to 6 means what I will do? The top 6 closest point. If I take the top 6 closest point, okay, to this star, this 3 will be there. And then if you compare these 3 are the new closest point, right? If I take top n, top 6. Now if I check in top 6, how many are very much, how many points are very much, uh, how many points are from top 6? So this is 1, this is 2, this is the third, let's say this is the fourth, this is the fifth, and this is the sixth. Out of 6 points, I can see 3, 4, 5, 6. All these 4 points are yellow class. Only 1 and 2, only two dots, only two nearest neighbors are from blue class. So if I change k from 3 to 6, my class is also changing. So the model will predict that star is belonging to yellow class rather than blue class. Understood? The main agenda is to let you know how important the value of k is, right? So choosing the value of k is really very important. Now your question is how we can find out how many, what is the value of k? We cannot always randomly take, right? How we can find out, right? That is the question. So we will see how we can find out. But as of now, you understand, right? What is the value of k? If you simply change the k value, the prediction of class is also changing. Okay. So now let's see. Okay, so that is what sort the points in your data by increasing distance from x, predict the majority label of the k closest point. So this we have seen. So this is simply the visualization of what I am talking about. So see, choosing k will affect what class a new point is assigned to. Just now we have seen, right? Choosing k will definitely going to affect which class the new point is belonging to which class. So see the picture number 1, figure number 1, k equals to 1. Okay, so you can see the points are not that much. K equals to 1 means only the nearest point, the top nearest point we are seeing. So that is actually giving not giving us very good result. But when I changing k equals to 5, then it is like pretty here you can check in the board here in this area it is pretty confusing. It is not clearly segregating, but if I say k equals to 5, it is giving us pretty good result. So the main question is how to choose k. Okay, so for what value of k we will the algorithm will give us good result. Okay, good result in the sense the algorithm can predict the result very well manner, right? Choosing of k, how we can choose the k value, so that we will see. But before that, let's see what are the pros and cons, because these pros and cons are really helpful for you when you are choosing an algorithm, right? In real life, nobody is going to tell you which algorithm you have to implement. Just by seeing the data set, you need to decide whether you will apply KNN or you will apply SVM or you will apply decision tree or what algorithm you need to apply. Okay, so that reason it is very important to know the pros and cons. So what are the pros for KNN? It is very simple and it works with any number of classes. Training is trivial, easy to add more data, few parameters, because here nothing we are checking, only the k is the one parameter we are passing. And distance metric, the distance, the step number one, calculating distance. There we are like using different Euclidean distance or Mahalanobis distance, what distance we want, that we are using. And k is nothing but how many neighbors you want. So again, it is very simple, works with any number of classes. Training is trivial, easy to add more data. These are the advantage. Okay, what are the disadvantage? It is not good with high dimensional data. So it is exactly reverse of SBM. Okay, SBM is very good for high dimensional data. So by seeing the data set, if you have very limited features, so you can apply KNN. And if you have so many features, like the dimension is very huge, you don't think about applying KNN directly. You can apply some other techniques like SVM. Okay, and other cons is categorical features don't work well. Definitely, if you apply common sense, categorical feature is like gender, yes, no, male, female, all those things, right? So finally, we are calculating the distance, right? So if it is numerical value, the distance between point we can calculate in a more good manner rather than categorical distance. That's the reason categorical features don't work well. High prediction cost. Okay, so it has a high prediction cost, worse for large data sets. It is not good for very large data set because we have a high prediction cost. We have simply seen just by like changing the key value, the entire class is getting changed. So it is a like prediction cost is here higher. Okay, not suited for large data set and high dimensional data set. If your data set is very small and with very limited feature, you can think of applying KNN. Okay, so this is the theory behind it. There is nothing like much in programming. We will see how exactly we can choose k. Okay, so there is a method known as elbow method which we can use to apply I mean to choose the proper k value. Okay, so we will see that visualization way, we will see that how we can do that. Okay, so you have been given a classified dataset from a company. They have hidden the feature column names but have given you the data and target classes. Got it? So sometime this happens in real life. Okay, let's say I am working with some like GE aviation project. So I have no idea about the domain. Like I don't know exactly the terms which GE is using. It's a manufacturing company. So many different complex term. I'm a like completely different background, but they dump their data set and they are trying to. They just tell me the problem statement. So I may not be able to understand what exactly each column is. Let's say one of the column is ESN, one of the column is ISN, one of the column is customer CD number. So what I will understand? I will not understand anything. I simply have data, but the columns are not clear to me. In that case, your manager told this is the target class, only the target class he will tell, and you have to predict. I mean you have to, for a new data set you have to predict the target class. That is the like problem statement. You have no idea about the column names. So in that case, if you can see your data is in numerical format, randomly you can apply KNN in that case if you don't have any idea. Okay, and it will give you good result also. So similarly, let's see one data set. Okay, so the data set I will be dumping. So data set, this is pretty simple. We are reading the data set, storing into a data frame. So this is the data set. Okay, the column name you can see some random, we don't know, SBILQUQWG, we don't know what exactly it is. What we have some numerical data with a target class. So this is target class. There are two targets, 0 1, two classes, either 0 class or 1 class, and we have some kind of data. Okay, we don't know what exactly that data means. So now what we can do? Okay, now how we can apply k nearest neighbor here. Okay, so before proceeding, always remember, before see sklearn use we already know by seeing last two or three, but we cannot apply directly sklearn library here. Before that, one pre-processing step is there. What is the pre-processing step? As because KNN predicts the class of a given test observation by identifying the observation that are nearest to it. The scale of the variable actually matters a lot. The scale of the variable, so these variables are not in proper scale, right? So they are varying very highly. So it is 0.97. Luckily it is closer to each other, but in real life data set the scale may not be same. See, in your data set maybe some values are like 1,000, some values are 0, some values are negatives. So the values are not, the variable values are not properly what, it's not properly scaled. So before applying the KNN algorithm, any variable in large scale has a much more impact. That's the reason we need to standardize everything to a proper scaling. Okay, we need to standardize our feature set to a proper scaling, right? Before applying KNN. That is a step number one. Okay, that is a pre-processing step that we are going to do here. Okay, so what we can do here is, there is standard scaler available in sklearn. You can, that is nothing but a pre-processing step, so you can import that. Here we are importing the standard scaler. Okay, now what we can do, we imported. Okay, step number 2, we created an instance. Okay, just now we are creating, right? Once importing any of the sklearn machine learning algorithm, we're creating instance. That is second step. Step number 3, scalar dot fit. What we are fitting, we are fitting all the other feature except the target, okay, to this scalar dot fit method. So what is we are doing, df dot drop, what you are dropping, the last column target class x is equals to 1. So if you remember, I told you x is equals to 1 means always it will work in the column values. If x is equals to 0, it will work on row values. So as it is 1, we are working with column values. And what we are going to drop, we are going to drop the target class. Okay, the target class we are going to drop, df dot drop target class. So except the target, all the other whatever except the last column like 0 1, all the other feature we are scaling all the data, okay, using the scalar dot fit method. Now what we are doing, once we done, we are actually transforming again. This is step number 2. Once scaling is done, again we are scale feature, we are transforming it. Okay, so if you want to know exactly, what you can do is you just add one line. Okay, here you want a print, here you want a print of this. Okay, and here you want add a print of this. Then you can see what exactly the scaled features are and what exactly this is doing, the output. Nothing but it is representing in a array format, numpy array format it is giving us. Okay, array format you know, right? So the data is like in this format. So minus the first is this data, right? This data is in this format, 0.12. I'm not writing everything, comma 0.18, right? One row is 1, again comma second row this value. So minus, so in this format, you know, numpy array, it is not doing nothing but it is scaling, in the sense everything it is scaling and keeping it in a numpy array. You can print the output, just write two print statement, scale print scale feature and write a print before it. You can see what is the difference. Okay, so again till here what we have done, here to here we have done nothing but pre-processing, scaling. Okay, pre-processing, and that is what pre-processing we have done, we have scaled our data. Okay, scaling is very important because we are depending on the distance in KNN. Done. Now the same agenda whatever we are like doing. Okay, so here what we are doing, again after scaling, as I told you, it is a numpy array, so we are converting it back to a data frame. Okay, so here df dot columns -1 is nothing but all the column name except the last column name, because there is no target, right? So we got our back with, we got the data frame back with a scaling feature, all the data are scaled here. Now what we can do, the same like train like sklearn as usual. What we can do, we are calling the train test split, and we are splitting it. Then we are calling the k near neighbor classifier from sklearn, and then we are fitting our model with xtrain and ytrain, and we are predicting it the same way we are doing for all other algorithm. Okay, and finally we are printing the confusion matrix, which will give us the accuracy. So now if you check the accuracy is pretty good, it is 0.90%. So how to increase the accuracy? Let's say your manager told no, 0.90 is not a good accuracy. You have to give me more than 0.93 accuracy. It should be the threshold is 93% accurate, more than that. Now your question is how I can modify the algorithm, how I can customize it. So what you can do, one thing, as you remember in KNN, there is nothing but 1K and one distance. You cannot do anything with the distance. Okay, maybe you can try with different distance approaches, but that will not give you good result. Only thing you can do with KNN is you can choose a key value and check the what is the output it is coming, right? So how to choose a key value? That is the question. Okay, so definitely the key value which is giving us less error is the best key value, right? If we are getting error, let's say 50, when we are choosing k equals to 5, and we are getting error 30 when we are choosing k equals to 2, then definitely in the second case, when we are choosing k equals to 2, we are getting less error. So k equals to 2 is the best option rather than choosing k equals to 50. Okay, this is pretty simple common sense. Okay, that we are going to find out. What we are going to do here for k equals to I equals to range of 1 to 40, in the sense for k equals to 1 to 40, for each k possible value starting from 1 to 40, k equals to 1, k equals to 2, k equals to 3, like that, iteratively we are trying to find out the error. Okay, and finally we will plot the error in a graph, and we will choose the k which is giving us less error. Okay, so what we are doing, how we are calculating error? Here we are calculating error, we are predicting the result, and we are predicting I is not equals to real I. Means what? Predicted result, or we are taking the average or the mean of all those results where the prediction is not equivalent to testing, the difference, right? Obviously when the prediction is not equal to the real value, then only we will get some error, right? If it is equal, then it is 100% accurate. So taking all those error, and this error rate we are plotting here. Okay, so once we plot the error, we can see this is the error rate 0.567. For k equals to 1 or 2, the error rate is maximum, like 0.13, 0. In between 0.10 and 11. But you can see it is a elbow graph. It is known as a elbow graph. So elbow graph is what? At certain point it will go very decreasing, and then again it will increase. So you can check, if I take k equals to 35, okay, it will give us the minimum error rate is when k equals to 35. But I will not take k equals to 35. Why? The first answer is it will be very much costly because k equals to 35. Second is it may mislead me, like I may get very wrong result because I'm taking very high k value. Instead of that, what I will take is, maybe if I take some k value near here, there is a less point here, and maybe here some around here 20. So some around, if I take some around 18 or 17, like that, or maybe if I take something around 23, okay, 17 or 23, like that, if I take something, then maybe error rate is giving minimum here. Okay, so let's take k equals to 17, and again try to do the same thing what we have done. So in initially we have done k equals to n equals to 1, right? Now what we can take, n equals to 23 we have taken. How we have taken? Because by seeing here you can check the minimum is 20 something coming here, right? This is the point, and this is 25, so it is in between 23. Okay, so initially we have taken n equals to 1 and we got k equals to 1 and we got accuracy 0.90. Now I change the k value. Here I am taking k equals to 23. Okay, and I can see the output k equals to 23. The output is really like increased, like the accuracy it is 0.95. Previously it was 0.90. By changing the key value, I'm improving the accuracy, k equals to 95. Okay, so this is the main thing. So everything is similar. Okay, everything, the coding part is exactly similar. Only one step is like new here. You have to pre-process, you have to standardize your data, everything to a proper scale before applying, before calling k-means machine learning package. Okay, so this is k nearest neighbor. This is pretty helpful, and you can use it when it's like nothing is clear to you, don't know what to do with the data. Randomly you can apply KNN. Okay, if it is numerical and you have no idea what kind of data it is, nothing you are grasping from the data, it's complete random for you, just apply KNN. Okay, it will give you good result. Now the first is over. The second is pretty important, that is K-means algorithm. This two I chosen because it is like similar to each other, not very much, but at least in some concept it is similar and confusing also. So don't confuse. KNN and K-means are completely different algorithm. The first difference is KNN is supervised category, right? It is a classification problem. We'll be having a target variable there. In K-means is completely unsupervised category. If you remember, the difference is there will be no target variable, there will be no outcome, there will be no result, right? So K-means is completely unsupervised category. KNN is supervised category. So now how, what exactly the theory behind it, let's see. So again you can read chapter number 10 from the Introduction to Statistical Learning book. Okay. So this is the algorithm for k-means clustering. What we are doing, k-means clustering is an unsupervised learning algorithm that will attempt to group similar cluster together in your data. So we don't have any target value. We don't know how many. So randomly, without see any data of the universe. Okay, if it is in numerical form, give me and I'll apply k-means and I'll tell you whether any similarity is there or not. Okay, so let's say YouTube data. You dump YouTube data and you apply k-means on YouTube data. So maybe some hidden pattern, based on some hidden pattern, it will give you some cluster. So high chance that people who belongs to one particular cluster have at least some kind of similarity. Maybe they are similar on the basis of age, maybe they are similar on the basis of gender, maybe they are similar on the basis of purchase pattern, or maybe they are similar on the basis of YouTube video watched. Some hidden pattern is there. Based on that, it is clustering everything into similar users. It is clustering into one clusters. You don't have any class to predict here, no. So what is here to predict? When a new data will come, which cluster it will belong to. Okay, so take an example of YouTube. Okay, you have YouTube data. So I apply k-means on YouTube data. So what are the columns? Let's say age, gender, and location ID. Okay, I mean altitude and latitude and all. So all those four columns I have. This data, there is no target, nothing, only four. Okay, age, gender, and latitude, and all this distance. I mean all this location details. That's it, nothing else. Or maybe age, three columns are there. Let's make it simple. Age, gender, and address. That's it, nothing else. Only three columns in the data set. And your manager told me, can you tell me anything, any machine learning algorithm can you apply? Can you infer any insight from this data set? It's a random data set which consists of age, gender, and uh, address. So what you can do, leave about address, we cannot do anything because it's textual data. Age and gender, okay, or maybe some other value, numerical value, if we can convert the categorical data to numerical feature using some of the techniques. Okay, that also I will tell you in the class. So finally, what we can do is we will apply k-means, and let's say we got three clusters. Okay, so one cluster is, let's say, all the female category. One cluster is all the old age people, age category. One cluster is, let's say, some different, maybe some pattern of something, some hidden pattern. We also don't know in what pattern the algorithm will cluster, but it is pretty sure the people who are from one cluster definitely have some similarity. What similarity they have, you have to find out. Okay, so that is the main agenda. There will be no target class. Okay, it's all about, it's nothing about classification, it's all about clustering. Okay, I mean it is very Like in interview they may ask you what is the difference between supervised and unsupervised. Okay, so you should able to explain them. So what is the algorithm? It is again very simple algorithm, nothing complexity uh, indulged with it. So what is the algorithm exactly? Cluster similar what are the use cases? Okay, so sometimes use cases gives us good idea. So what kind of problem you can resolve using k-means? Cluster similar documents, that is one. Like uh, out of million of news you can cluster news on the basis of category: entertainment news, then maybe highly rated news, highly viewed news, some category. That is cluster similar documents. Cluster customer based on features. Market segmentation, identify similar physical group. So all this kind of similar kind of groups, if you want to find out, you can use k-means. The overall goal is to divide data into distinct groups such that observation within each group are similar. Okay, the main agenda is, as I told you, divide data into distinct groups. We are doing nothing but dividing the data into distinct groups such that observation within each group are similar. Okay, so now how the algorithm works? Step number one, choose a number of cluster k. Okay, what is k here? In k means what is k? K is nothing but number of cluster. How many cluster you want? 2 cluster, 3 cluster, 5 cluster, 10 cluster, how many cluster you want? Excuse me. That is the key value. Okay, then second, randomly assign each point to a cluster. Point number 2 is randomly assign each point to a cluster. You choose, let's say I need 4 clusters. Let me show you here. No worries, I'll show you a very good video on YouTube so that it will be helpful to you understand. So step number 1, okay, so we have all this point. Okay, so let's say we have all this point. Okay, so what is my first like point number 1 is, so random choose number of cluster. Let's say I choose here k equals to, let's say I choose 2. I want 2 clusters. Okay, step number 1 over. Step number 2 is randomly assign each point to a cluster. Randomly, no need to. 2 cluster, okay. So randomly choose any 2 points. This is my entire data set. Randomly choose. Let's say this is one, randomly assign each point to a cluster. So let's say this is my centroid, and let's say this is my centroid. These 2 point you randomly choose, and based on distance you assign all the points. So these points are closer to this, these points are closer to this point, right? So randomly, completely random, any 2 point you can choose a centroid and assign all other points to their centroid based on who is closer to which point. Got, finally you got 2 cluster, right? Until clusters stop changing, repeat the following. Then once you done that, step number 3 is for each cluster compute the cluster centroid by taking the mean vector of the points in the cluster. What you will do, once step number 1 is over, step number 2 is again you have to find out the centroid. How to find out the centroid? So this is my 1 cluster and this is my 2 cluster. Okay, I want to find out the centroid of this. How I can find out? Again, for each cluster compute the cluster centroid by taking the mean vector of points in the cluster. So take the mean. What exactly that mean? Maybe by seeing a video it will be clear. Take the mean of each point. Okay, mean vector, and that will give you a new centroid. So let's say the new centroid is a point. Okay, so let's say this is the new point, new centroid. Okay, and let's say for rate, the new centroid is, let's say this is the new centroid for this cluster. Do the same thing, repeat step number, like here whatever, like randomly assign each point to the cluster. Here again calculate the distance. Now this point which is here, or maybe you can here. Okay, So now this point, let's say this point was previously belonging to this cluster, but now let's say this is closer to the new centroid. So this point will belong to this cluster. This point will belong to this cluster. So similarly, again, a new cluster will get. Okay, let's say this is a new cluster. What you will do, again take the mean and find out the new centroid. Again try to find out the distance. Keep doing the same thing again and again. Okay, so that once what will do, no matter how much you are changing, the centroid will remain same. You cannot change the centroid. That is known as you reach the threshold. Stop there. Okay, maybe through the example it will be better, and I will also show you one video, YouTube video. Okay, so this is the algorithm. Let's see here. In step number one, we have data, right? It's scattered, nothing is clear. Just I represent the data here in XY plane. Step number one. Okay, step number one, what I will do, randomly assign each point to one cluster. Randomly assign. Step number iteration one, step number 2A. What we will do, find out the centroid. Okay, so how to find out the centroid? So here what I did, let's say this belongs to, I have k equals to 2. Okay, so let's say we have here 3, right? So k equals to 3 classes. So step number 1, this point you should belong to cluster number 1, you should belong to cluster number 2. Random, right? Anything. This point, let's say cluster number 3, this point, let's say cluster number 1, cluster number 2, and I do different coloring code. So finally, once I done this, this is my step number 1 result. Then what I will do, I have all these 3 colors which are nothing but 3 different clusters. I'll try to find out the centroid for each uh, cluster. Centroid is nothing but the mean vector, okay, of all the points of that cluster. So I'll get, let's say, clusters. These are the centroids, which is not pretty clear. So they are like overlapping each other, the centroid. In iteration 1, step number 2A. Iteration 1, step number 2B, what we will do? Again, we will recalculate, repeat the same thing. Based on the centroid, whoever closer points are closer, again assign, again repeat. Similarly, if you iterate so many things, finally you will get 3 clear cluster here. Okay, so let me show you the video, maybe that will be better, because all these things without visualization very hard to understand. Okay, so this YouTube video is very good. I will send you the link. This is Stanford University video. You can please go through it, not the theory part. Just from here you just listen. Okay, whatever it is saying, just listen.
K is equal to 2. So we're looking to find 2 clusters in this data set. Now, in round 1, I'm at random going to pick 2 points since K equal 2 and call those the centroids of the 2 clusters. Let's say I pick these 2 points, the point that I've highlighted with the in pink here and the point that I've highlighted in blue here as the 2 centroids. I pick these totally arbitrarily and at random. Now, what I'm going to do is I'm going to go through all the data points, and for each data point, I'm going to assign it to the centroid that it's closest to. So observe that this point, for example, here is close to the red cluster. So I'm going to assign it to the red cluster. Whereas this point here is closer to the blue cluster than to the red cluster. So I'm going to assign it to the blue cluster. And when I go through all the data points and do this, here's the clustering that I end up with. These 2 points here end up in the in the pink cluster here, and this set of points are closer to the blue point here, and so they end up in the blue cluster. So that's round 1 of k-means clustering. Now what I'm going to do now is, because I've created these 2 new clusters, I'm going to compute their new centroids. And when I compute the new centroids, the centroid of the pink cluster moves over a little bit to the left to this new position here, and the centroid of the blue cluster moves to that new position. Now, because I have new centroids, I'm going to go through in round 2, I'm going to go through each data point again and assign it to its closest centroid. And when I do that, observe that point, for example, this point here is now closer to the pink cluster than it is to the blue cluster, and so it moves from the blue cluster to the pink cluster. Okay. And so we have this new clustering at the end of round 2. Now that we have the new clustering, I'm going to recompute the centroids once again. And when I recompute the centroids, the centroids migrate further. And because the centroids are migrated further, I have to recompute the assignment of points to the centroids again. And when I do that, these two points here then are closer to the pink cluster, so they move to the pink cluster, and we end up with the clustering shown here at the end of round three. Okay. Now, as it turns out in this case, round three is the last round. At this point, the centroids and the points don't migrate any further, and we have a stable clustering. So what we have here is the clustering, the k-means clustering for k is equal to 2 for this data set.
Got it, the concept. So how exactly it is working? Any doubt in the theory?
No, it's very nice.
Yeah, so I will send you the link. Please go through it. It's very good video for understanding the theory. Okay. So this is how exactly K-means is. Okay. So you have to repeat the same thing again and again until your centroids are not changing. That is the main thing. Okay. So this is how the K-means is. Now, uh, so like yes. So now the question is choosing the K value. Okay. Here also the challenging part is how to know for which K value we will get a very good result. But here the concept is again similar to what we have seen in K nearest neighbor. What we can do is, so we will plot the error rate in a graph and we will apply the same elbow method. Okay, there will be one sharp decrease end and then from again there will be again an increase end. So we will take some K value nearer to that point. Similar, very much similar when with the K nearest, how we are choosing K there through an elbow method. Same method we can apply here for choosing K. Okay, there is no easy answer for choosing the best K value. Whatever we are doing is like somehow it is like you can say assumption. Okay, but there is not straightforward answer for this question how to choose K. No straightforward answer. Just using elbow method we can do that. Okay. So first of all, compute the sum of squared error for the values of k. Okay. So here, there we were calculating the error rate by taking the average, right? Here we are calculating the sum of squared error, that is SSE. Okay. So which is nothing but compute the sum of squared error for some values of k. Okay, let's say for k equals to 2, you calculate SSE, k equals to 4, you calculate SSE like that. Then plot all this. What is sum of square error? Is nothing but sum of square error is defined as the sum of square distance between each member of the cluster and its centroid. Okay, the sum of square distance between each member of cluster and its centroid, right? That is SSE. So no worries, there is already package available. Simply call SSE, it will give you the SSE for that centroid, for that cluster. Okay, find this SSE, represent it. If you plot k against the SSE, you will see that the error decreases as a k gets larger. If you increase the k value, the error is decreasing. This is because when the number of cluster increases, they should be smaller. So distortion is also smaller. The idea of elbow method is to choose the k at which the SSE decrease abruptly. So as I told you, shown in the graph, abruptly means what? Sharp decrease. You can see it. That is known as elbow method. Okay, just after plotting SSE, you can see there will be some point where it is a sharp decrease. I mean, uh, what you can say, cone kind of structure. You can see cone. So that is known as, that is the proper k value you should take. Okay, see this graph. If you plot the graph with respect to SSE, so when k equals to 6, okay, see there is a very very sharp decrease of SSE when k equals to 6. After that, it is not that much decreasing, the SSE values. It keep decreasing, but not that much. In a very slower manner, it is decreasing. But when you change your k from 4 to 6, there is a huge decrease in the SSE. So you should check, by seeing this graph, you should say that when k value is 6, maybe my algorithm will give me best result. Okay, that this is one of the like way you can which can help you choosing k values. But again, there is no solid method for that. Only through this elbow method you can assume. Okay, so the coding is again not that like, okay, so leaving the top. Okay, so it is pretty simple, nothing difficult. So what we are doing is, um, we are first creating some data. Okay, so this create cluster data is nothing but we are creating some random data. We don't have any data set. We are randomly creating some data. So what we are doing nothing but, what we can say is, um, we are points for cluster. So this thing you can skip because we have data set directly, we can load it. Okay, I will come to this part later. Let me show you the normal procedure how we follow. Okay, so again, let's say we have our data. Okay, let's say data is something which we have. Here we have created, but let's assume that we have our data ready. Then how to apply k-means? It is pretty simple. Simply first step is import k-means from sklearn, and then call the k-means method with number of cluster you want. Number of cluster equals to 5, 6, how many you want, that you specify here. And very simple, like call the fit method. And while again, as I told you, all this distance related algorithm needs to be a scaling is essential. That's the reason we are calling the scale method to scale, as we have done in the previous k nearest before fitting the model. So model, our model is ready. If you see, print model dot labels. Okay, so I am giving, it is giving us four labels: 0, 1, 2, 3, 4, means we have total four clusters. Okay, so then what we can do is, if I show my data, if I do a scatter plot, okay, with all the rows and the zero column of the data, and with all the rows and the first column of the data, okay, which is nothing but the x and y value, I can see I am getting four different clusters. Okay, so the procedure is pretty simple, nothing great. You have your data set, you have to import sklearn k-means method, then you have to convert, you have to scale your data set, that is known as scaling. Then you can call the k-means method by passing number of clusters you want. You can call the fit method, so which can fit your data or maybe build the training model. There is no predict method here, directly you can like see the labels using labels. There's a method known as labels which will give you all the labels of your model. Okay, so if it is confusing, what you can do is, don't go with this, go with a proper data set. I think that will be better. Okay, so maybe coding part we can see in the next class. Okay, I just want to let you know, I just want to implement this k-means on top of a proper data set, not by using some random data. Okay, so we will do it with a proper data set. We have a data set, how we can apply k-means on that. Okay, that we, coding part I am leaving. Maybe in next class we'll see the coding part. Okay, so if you want to like understand what we are doing, so here we are doing nothing but whatever I told you, we are doing, right? Like if you want to understand, like create cluster data n and k. So when we are calling this method here, right, so here when, here we are calling, so x n equals to 100, k equals to 5. Okay, 100 samples 5. Now what we are doing, points per cluster equals to floatum n by k. How many points will be there in each cluster? There are total 100 records and 5 clusters. So 100 divided by 5. So 20 points will be there in each cluster. So we are doing some random thing. Okay, you can skip it. It is nothing related to real life. This is some random thing we are doing. You can skip it. So let's make some fake data that includes people clustered by income and age randomly. So we are creating some random data here. We are doing nothing but creating some random data. Okay, so this income centroid is nothing but a data which is uniformly distributed, 20,000 records in this range. Now a centroid is nothing but again a different data with this range. Now for each that we are what we are doing, so we are actually taking the normal of that. This is nothing, you can skip it. Okay, it will confuse you. Is doing nothing but creating some fake data and then we are using here. But in real life, in real time, in company, nobody is going to tell you to create some fake data. They will give you the data and then they will tell you to apply K-means algorithm. So here if you have the data, simply you can import the K-means, you can call the K-means method with passing number of cluster you want. Then you can call the fit method to create the model, right? Then you can use the model. That's the same procedure we are following every time. Nothing different here. Okay, but I will try to make it as simple as possible. Maybe in the next class I'll find out some data set, a real life data set, and I will apply K-means on that data set. Let you know. Okay. So next class we are going to start big data, Apache Spark. Okay, so there are few other algorithms which I want to show you on top of, because we already know the pattern, like how we can apply sklearn. Let's see on top of big data how we can apply machine learning. Okay, so I'll show you how regression can be applied on top of machine learning algorithm, like on top of ML library of Apache Spark, and rest all other like collaborative filtering, recommendation engine, how we can implement on top of Apache Spark. So before that, installation is required, right? So next class I'll tell you how you can integrate your system with big data tool like Apache Spark. So if your system is not ready, by next class you please make it ready. Minimum requirement is 4 GB. That is more than enough. If you have 4 GB of RAM, that is more than enough. Okay. So uh, it will take hardly 5 minutes to integrate. Hardly 5 minutes. Let me show you. Okay. Uh, Today's class, let me show you that. This K-means coding I will do again. Don't worry. Okay. If you don't understand, don't worry. I'll do again in the next class. So what I am telling you is integration of Apache Spark. What is Apache Spark? Architecture of Apache Spark. Everything we will cover. Don't worry. I'll give you a crash course, very nice crash course. So which will help you to understand what exactly Apache Spark is and how it is helpful for data science and what are the functionalities available, how to use it. But before digging the theory part of Apache Spark, let's install it first. Okay, so I am telling you the installation part today only. Okay, so it is pretty easier. So you have Spider, right? You have Spider. Once you open Anaconda Navigator, as of now we are using Jupyter Notebook. Now we will use Spider. Okay, because we are going to integrate our Apache Spark with Spider. Okay, so what we can do, you can you can create, you can open your Spider. The class recording you follow after the class is over, when you are installing the same thing on your machine, just follow the class recording. Whatever I am doing here, just do the same thing on your machine. It will be getting installed. Okay, hardly it will take 2 minutes. It's not working. Hanged. It will take some time to load. Okay, so it is taking some time to load. Okay, what I can do is maybe in the next class I'll show you. Okay, so next class, what is the takeover for next class? Next class we are going to see the coding of K-means. Okay, then we are going to see how to install Apache Spark on your machine and few basics of Apache Spark. Okay, maybe 1.5 hour. Please keep some time reserved. Maybe we will start the class little earlier, around like I'll tell you the exact timing. Don't worry. So we will take some 1.5 hours. So all the Apache Spark basics, and I'll give you some books to read, and I'll tell you some PDF, some 50-60 pages of PDF I'll share with you, which will help you to understand the theory part of Apache Spark. In the class, I'll give you the summarized part, and then I'll install Apache Spark on your machine. That much we will do. Next class onwards, whatever machine learning algorithm we are going to implement, except decision tree, that is that we will apply in Python, or maybe if you want, we can apply in machine learning itself. All other algorithm we will apply on top of ML library. So big data way. We will write our program in big data way so that you will get both flavors. Okay. Any doubt for today's class?
I have a quick question.
Yeah, yeah, sure.
Hello?
Yeah, yeah, yeah. Hello.
Yes, Asante, yeah. So, yeah. So during clustering
Mhm.
and k-neighboring thing, so
Uh-huh.
if I like to make a graph, like the which points are in my data sets are for the analysis.
Okay.
So, like what you call super curve or something.
Mhm.
So that I can also make, right?
Yeah, yeah. You can. You should actually make, because that is the only method which will give you an idea to choose the k value. Okay. Both in k nearest and k mins, try to find out the error rate. Okay, and then try to visualize the error versus number of k. Okay, so what is the error when k equals to 1? What is the error when k equals to 2? What is the error when k equals to 5? Right? So if you visualize the error, you will get some point, a particular point. It is giving a cone like structure. Cone, you have seen cone, ice cream cone, right? So one cone like
Mm-hmm.
structure you will get. Okay, so cone like structure in the sense sharp decrease and then again increase. That kind of structure you will get. So take the cone point as the key value. That is known as elbow method. Okay. So from the
Okay.
graph only it will be
Okay.
very clear. Okay. So here you can check. You will get a cone like structure. So that you have to take. I think not here. So a sharp decrease here you can see. It is only for 14, but if you plot for more key values, it will again increase. Okay, it's not like always it will decrease. Again, it may all again increase. But you can see here it's 6. It is a sharp decrease, right? Little decrease.
Mm-hmm.
And here at k equals to 6, it is a sharp decrease. It's like a cone. So you can check this is the point where you should stop. So k value must be 6 here. So again, there is not 100% guaranteed. Okay, as this is only the trial, and you can say some some approach. It's not solid approach. It's just a trial and error
Okay.
method. Okay, at least some idea you'll get.
Okay. Okay. That's fine. Thank you.
Yeah, thank you so much. Yeah. Okay, guys, and there is an assignment for K nearest neighbor. That is a project. You please go through it. Okay, I'll upload it by today. Okay, thank you.
Okay. Thank you. Have a nice day.
Yeah,
Okay. Bye
same to
bye.
you. Yeah, bye.